Okay, question 11, they give you this situation where you have an object hanging or suspended horizontally by two ropes. Okay, T1 and T2, given that T1 is equals to 49. Okay, they did give you the values of T1, which is over here, 49.05, and the length of the ropes is equal. Calculate the values of T2. Okay, this one actually in real world you wouldn't get this kind of situation lah. The main thing is because this one is, if this one is a ropes, obviously you will have a slight angle. Even if it's minimum, you need to have the angle so that it will balance off the weight over there. Okay, or as if something like this, you will have a, if I try to draw the free body diagram, and then maybe you can see why it doesn't make much sense. It's okay, this is just a question, so don't worry about that. If I want to draw my free body diagram, then I will have tension going to the left and to the right, and my weight going downwards. So this will be T2, this will be T1. Okay, and this is my weight. Okay, so as you can see, if this one is, I mean, it's supposed not to be moving lah, because it is suspended, so you expect that the A will be equals to 0, or this one is at equilibrium. So basically you need some force to be balanced off. So example here, the weight, you know, it need to be balanced off with something lah, but there's no something. So this something comes from the slight angle over here that will results in Tx and Ty. So basically your Ty are supposed to balance it off, but it's okay. This is just a question. So they want to find T2, so maybe I can try to solve from Fx. Again, I always write this one. It's very important because sometimes you might get 1 mark if you write this one. So imagine, write this one, you get 1 mark. Why is equals to 0? Because it's at equilibrium, so acceleration is equals to 0. So marks, if they give, it will be because of the concept mark. So T2 minus T1 equals to 0. Okay. Is this just a question? I mean, yeah, this is the question. I mean, it doesn't do much calculation, but it's okay. Okay, it's okay. That's good. Easy is good. Question B. Okay, you have an object, okay, suspended by two ropes at an angle. So you have two ropes, T1 and T2. So whenever you have more than one rope, you cannot assume that the tension is the same. So it could be a two different tension lah. So if I want to draw the free body diagram, I have T2 over there, T1 over there, and obviously I need to have my weight as well. So this is something that is more logical. So you have Ty that will balance off the weight. So it makes sense lah. Again, this is at equilibrium. You can think about it like something that is hanging, it's not moving anymore. Okay, the information that they give you is the weight. Interesting. Okay, now you can try to draw the free body diagram. My free body diagram would look something like this. Have two tension in those direction. Okay. Okay, so maybe I can try to determine the angle first. So from this diagram, you can see that this is basically my zigzag angle. So this one would be my 60 degrees. Same things happens over here, where this one would be my 30 degrees. Okay, it does make sense. So if I want to draw it on my free body diagram, which you should draw, if the question asks you to draw the free body diagram, you really need to label the theta. Okay, you got marks over there. So this one is 60 degrees and this one is 30 degrees, and don't forget to put T1 and T2. Okay, so free body diagram, you draw it like this, you get 2 marks. Find the tension T1 and T2 in the ropes. I'm going to make this one maybe a little bit smaller so that it doesn't interfere with what I'm going to do next. Just put it over there, and I think we can solve it over here. So summation of fx equals to 0 and summation of fy equals to 0 because this is at equilibrium. So x and y component, both of these a equals to 0. And then if you want to resolve, then you will expect t2, you have t2x over here, and you also have t2y over here. And the same thing happens for t1. This one will be t1x, this one t1y. Okay, and remember, if it is to the left, it will be negative. So x component first, you just have to look at this horizontal line. What are the forces on these lines? You will have on this line, you will have t2x and t1x. Okay, so just these two forces. So it will be t2x. Okay, why this one is positive? Because it is to the right, minus t1x because t1x is pointing to the left, so I put that one as negative, equals to 0. Okay, t2x is basically your t2 cos 60 degrees minus t1 cos 30 degrees equals to 0. Okay, before we calculate, maybe you can try to do the fy as well. So this one will be t2y plus t1y minus weight equals to 0. Why the weight is minus? Because the weight is pointing downwards. So now you have t2, it will be sine 60 degrees plus t1, I just go this one really slow because I might mix it up, 30 degrees minus, the mass is given, which is 10. So this is 10 times 9.81. I cannot fit it over there, so I just write down the G there. Okay. Okay, now you can solve this one. You can try to press your calculator and see what does cos 60 is 0.5. Interesting. So it will be 0.5. Just type my pen a little bit. So it will be, okay, it will be 0.5 t2, which is equals to cos 30. Now you have 0.866 t1. Okay, and I can do the same over here. So sine 30 now would be 0.5, and sine 60 will be 0.866 if I'm not mistaken. Yes, it will be 0.866 t2. Okay, plus 0.5 t1 equals to 98.1, which is basically 9.81 multiplied with the 10. Okay, so now I have my first equation and my second equation. So again, I will try to show you one by one so that you guys didn't miss anything. So substitute t 1 into 2. I might have to take a break after this. Okay, then I will have 0.866. Okay, I will try to substitute t2. So basically I bring this one down there. Okay, so 0.866 multiplied with 0.866 t1 divided by 0.5. I just have to be careful so that I didn't mix anything up. Okay, and I think I got it correct. Okay, plus 0.5. Again, t1 just leave as t1. Okay, So you know that you can solve this equation because basically you have two variables with two equations. So just two variables with two equations, then you know straight away you can solve lah. If you have three, then something is wrong. If you have three variables but two equations, then maybe you have to rethink a little bit. Anyway, this one would be 0.866. 0.866. I hope I got it correct. Okay. So I got here is 1.499. I roll it off to 1.5 T1. So basically I have 2 T1. So my T1 now becomes 98.1 divided by 2, which is 49.05. Okay, I think slightly different with the final answer, but it's okay. Okay, just a matter of decimal point. Anyway, now I have this number. I can substitute back inside the first equation to make it easier. So substitute into 1. Okay, then I will have 0.5 T2. So T2 equals to 0.866. Okay, multiplied by T1. Okay, and then I bring the 0.5 down here. Okay, so it will be divided by 0.5, which is T2 equals to 84.95. Okay, again, slightly different than the given answer, but again, don't worry about it. Okay, as long as the calculation is correct, should be okay. Okay, question number 12a. I already write it down for you again to save some time. So what is distinguished between static friction and kinetic friction? So basically by the definition itself, kinetic friction exists when the object is moving. On the other hand, static friction exists when the object is not moving. That one is obvious. Okay. Okay, now for question B, 30 kilogram block is placed on the inclined plane. I try to make this one. Okay, I'll just leave it like that. Okay, I think I got enough space here. Okay, B, draw a free body diagram to show all the forces acting on the block. So this is the block. So first of all, you identify all the forces on here. It says that it does have the coefficient of kinetic friction, indicates that this is a rough surface. Okay, and then I have my normal force over there. Okay, my weight over there. Okay, now the question is, where would be my friction? Okay, so if you want to determine direction of friction, you can imagine what will happen if there's no friction. Okay, let's say this surface over here is smooth ataupun licin, so you will expect this one will slide down lah. It will go down in this direction. So if this object move in that direction, my friction will be in that direction. So basically in this case, the friction will try to prevent the object from moving. So the friction will try to move in this direction. Okay. Plus I think this object is moving, so I thought that this object is not moving. Okay, so since this object is moving, so obviously it will move downwards lah. Kalau dia naik atas tu pelik pula. Okay, so it's moving, so it's kinetic friction. It doesn't say anything. So basically we assume that it moves by itself. Interesting. Okay, now I can draw the free body diagram again. For free body diagram purpose, if they ask you to draw, I really prefer if you just draw the three, in this case it's the three basic forces. You don't have to resolve anything yet. You certainly don't have to rotate it, but if you want, it's up to you. Okay, again, and like how I always told you, the angle there represent the angle towards the y component, so you don't have to draw, or you don't have to find it every single time. Okay, but as long as it is between the surface slanted surface here, and the horizontal, that angle represent towards the y component. So that one you need to show in your free body diagram, or else we lose, I think, 1 mark. Okay, how do you get the 20 degrees? I'm going to show you one more time. Maybe last time, but I'll show you. So this one, this is basically the right angle triangle. You can see clearly this is the right angle triangle for this part. Okay, oops. Okay, now I have to erase it back. Okay, the angle here will be 90 minus 20, which is 70 degrees. Okay, and if, let's say if I make this line a little bit longer, the end, which is 90 degrees to the surface and 90 degrees to there, then I will have 90 minus 70, which is basically 20. So again, this angle will always represent the same angle over there. Remember that. Okay, so you don't have to draw every single time. I mean, you don't have to find every single time lah. You know straight away. Okay, so draw free body diagram, double check, is all the forces are there. Seems okay, so correct. So just leave it like that. Okay, that one is for question 1. Okay, for question 2, okay, let's say if you want to calculate, now you might have to use the free body diagram that you resolve. So I suggest you to redraw with the different question header, so that if you draw it wrongly for your resolving vectors over here, let's say if you accidentally put this one as wy, you still get a full mark because this one is correct. So you just do it over there. Okay, that is just my advice lah. Again, it's up to you. Okay, so you have n. So basically the same thing. I should have copied that one. I think I'm gonna copy it. Okay, again, your force in your free body diagram, make sure to always include the arrow. Okay, so the head of the arrow you need to draw this one. This is what I'm talking about. Make sure this one is just the tails or the axis over there, so you don't have to do anything about it. Okay, and then indicates the direction of A. A would be in that direction because it is going down the slide. So the A would be in one of the axis. Okay, so this would be your x-axis. Okay, remember, the motion would be on the axis. If this one is not on the axis, then you will have a problem. You cannot solve anything. So we assume that this is basically your x-axis. So for the sake of learning, I'm going to write it down. Okay, but then in exam you don't have to lah. Since that is x, this would be your y. Just draw a straight line over there and over there. Okay, so now the only force that is not on x or y axis would be your weight. So you have to resolve weight into wx and wy. Okay, so here you can see that wy is w cos 20. If it goes from here towards the y axis over here, then it goes through the angle, so it will become cos. This one, there's no angle, it becomes sine. So I'll show you in the first chapter previously. Oops, what did I do? Okay, now to solve this one, maybe I can try to start it over here. Again, like I always told you, I always try to do fx and fy simultaneously. Okay, so that in case you stop, you can always try to look at the another axis. Okay, so this case A is in x component, so I put this one as MA over there. Okay, it doesn't state that it's moving with the constant velocity or anything, is it? So we assume it has an acceleration. Okay, I don't think you can solve. I think you can solve if it's 0, but again we assume that it's not 0 lah. It's moving at an acceleration, it should I think the question should state lah. Anyway, we try this one first and see how it goes. So for fx, which one I'm gonna do first? For fx, I'm gonna do this. Okay, so this one is your x-axis. How many forces are there on the x-axis? You have two forces only, which is wx minus fk, sorry. Okay, so you might not see this clearly, but this one is actually moving to the right. So it's positive. This one is negative because it is moving to the left. I assume that this is positive because it is to the right. Okay, so now wx is equals to, where I really have to read back the question, because the question wants to find the kinetic friction. I see. So I didn't read the question too. Just try to do it. Okay, so if you want to find the kinetic friction, so basically the question wants to find Fk. So you don't have to open up like mu n. I think maybe you have to. I just try to do this one. Okay, so for the y component, it will be n minus wy equals to 0. Okay, well, this is the only force that you have in y axis. Over here you only have n and wy, so it will be n because that one is upwards, minus wy is negative because downwards, equals to 0. So your n will be equals to mg cos 20 degrees. The mass is given, yes, the mass is given 30. I can find my n straight away, and if I want to find my fk, since the coefficient is given, so you can solve it straight away using this formula. Okay, again, you don't take this thing for granted. You really have to draw, you really have to solve until here. You cannot simply memorize. Different case will result in different formula over there. Example, if I have some force over there, okay, n over there and weight over there, so this one will contribute to the n here. If you got the question, then maybe you can understand quite what I'm saying. It's okay, just leave it like that. So what I'm saying is that always do this one. Okay, do not simply assume it is like this. Okay, don't assume. So this one is 0.2 multiplied with the n, which is 30, 9.81 cos 20 degrees. So the solution is actually easier than I expected. Okay, so how do I know that I can use, this one I got 0.94, so it will be in Newton. I think I got it wrongly, or maybe I look at different answer. Yeah, I think I got it wrongly. I think maybe try to press it one more time. 0.2 times 30 times 9.81 times cos 20 degrees. Yeah, I don't know what I write, what I calculate just now. I should get 55.31. Okay, so how do I know that I can use this formula straight away? I don't have to solve this one. It's basically because the coefficient is given, and since you know the n, you can straight away substitute inside here. You can solve without doing anything else. Okay, I think that's it for this video, which is question 11 and 12. Next video, hopefully we can cover question 13, 14 and 15. Thank you.